Hello, in this video you will learn how to use functions and stored procedures in PostgreSQL. And PostgreSQL stored procedures is a bit of a newer addition, and there are some certain differences. So we'll cover both the differences and in general how you would execute that and how you use it directly in PostgreSQL. In this case, we're using DBeaver, whatever you want to call the tool. It's a great tool for PostgreSQL, and also you can actually connect to SQL Server databases via the same sort of arrangement, the same program in Windows. The syntax will be what you use for PostgreSQL, so it's not exactly tool specific, but just to mention, this is the tool we are using for today's video. So let's get started and let's build a little example. We already have a table. Let's look at a table and then we'll write some code for stored procedures. We'll execute them. We'll write some code for functions and we'll execute them as well, and we'll see some differences between them. So the example here is very simple. We just have accounts table, we have owner and the balance. So we'll try to adjust the balance, add a bit to it, do something with it, basically the function and the start procedure, and you'll see some differences there. So let's get started with a function. To create it, we'll first need to simply create, right? But when we're creating a function, we're creating it and storing it essentially in the database. We're not executing it. It's not for one-time use. For one-time use, you just write a query and probably throw it out at some point, or maybe you save it. That's perfectly fine as well. For the function, it will be used and reused, so we need to store it and we need to create it. And then you can adjust it as well. You can update it to some extent in some ways. But let's get started with creating. So we do create, then we do function, and then let's call it account balance will be the function. So this, what it will do, it will simply retrieve the balance from the account. So let's do it like this, and we will need to provide not the account, the owner's name, but let's say the account ID. It will be simpler. And we just have, we don't use GID in this case. You could, of course, do that. That's not a problem. We can do account, let's see, account like this. Let's do a little shorter version of account. We could just use this full word here. It doesn't matter. And integer. So that's going to be the integer. Now, that will return something, so we need to specify what it returns. And what it returns is numeric value. Again, it could be something else and certainly not this. Let's see if we can actually go to the next line. We can. And then we need to specify the language as well. It's always a sort of good idea. You'll see there will be a bit of a difference in the next function we write, because we'll have a couple of them just to kind of play around with it. But as you can see, the parameter for the function here, it goes like this. It might be slightly different later on. It's probably about the same, but the way it's used and depending on the language, that might be a bit different. So we specify the language here. We don't actually need the casing like that. I just jumped off SQL Server, and that's kind of a thing to do there. So I'm doing that here, but certainly no need for that. And let's do SQL like that. And not SQL alter. Let's leave that like this. And let's call it stable, like this. And again, the same thing. And as a couple of $signs here to open the actual query. These suggestions, they aren't the best, and it's not like Visual Studio, for example, where they can be quite useful. They are more of an annoyance here, but nonetheless, the sort of spell checking, if you will, works quite well, the IntelliSense here. So with these, you essentially just open up the query itself, right? So you have the definition of a function, and we'll have a bit more of it. But here is the actual query that the function will execute. So let's do select, let's do balance like this from, let's say, accounts, that, where ID equals our little parameter here for the function. So this is our function, and now we have the create everything, and we can close it like that as well. We have it created, great. So now if we execute it, it will be created. As you can see here in the bottom, we just have the query returned. It doesn't really say if it worked or not, but you can check it on your database, just like you find tables. So you'll find functions, and same way you will be able to find stored procedures there. So we have this created. That's all great and good. Now let's get rid of this and let's execute the function. To do that, you need to do select. Let's do owner. Account. Let's do rather something simple, something a bit more simple. And this is sort of where the difference actually comes with functions and procedures. So what we're doing here, we're actually using select to get from the function or to get, well, something else. So we can do account. Let's see, can we do it? Account balance. That is our function, and of course it needs a little ID here. The ID we will provide like that. You could make this into sort of more complex thing, and we'll do that a bit later. So we have select account balance. This will get account balance for ID 1. Let's hope ID 1 is the place. If not, we will look it up and we'll change it. But that's the syntax in general. So that's all we need to do really, because we are just selecting the function. So now you can see it's executed. We have account balance 500 in this nice little grid. Perfect, all great. But you can actually combine them a bit more. So you can do something like this. Let's add a little comma separator here, and let's do owner, right? Because we have an owner, and you can do let's say balance as balance. So you do like any normal, let's actually do it maybe like this as balance. So like this as balance, and then from account. So you can actually mix it, and we don't need to do the A. We're not doing anything more with it. You could do again a bit more naming, and then if you have where, you can do filtering as well. Again, like any normal select arrangement, little query that you have, you can actually provide the function inside it. And then what you can do with ID, you can provide the ID that we retrieve from right here from accounts, right? So accounts will have an ID, and it will get the account balance from the ID. Now, this doesn't make any sense. We could just get the account balance straight from that. So there's really no point. But if you're dealing with more tables, if you're dealing with more complex arrangements, or some calculation more likely in a function, then you can do this. And then if we execute that, we get the balance. Of course, this is just for a little example, because we're just walking in circles essentially, and there's no point in it. If we do have a calculation there in the function, then yeah, it would be a bit different. But this is how you execute the function. You use select. So it goes into select, and then from select you retrieve result. That's all there is to it. And then you can do filtering and all that sort of stuff, and mix it up a bit. So usually it would be used in a calculation somewhere in your select, and perhaps it would actually be used in a stored procedure. You have little calculations as functions of maybe binding a few pieces of text, maybe doing something of that nature, maybe checking against another table, some specific records after some calculations, and then you output as select, and then maybe you output as stored procedure. So now let's take a look just quickly at another function here, and then we can move on to stored procedures. For the next one, we will have something quite straightforward, and something that won't exactly work as such. So let's get started here, and let's create another function, and I need to stop doing that. Create function like that. And let's call it transfer. Okay, let's call it balance transfer like that. Balance transfer. And we'll take account ID just like we did before, and we'll take some amount to transfer. So essentially we'll add, right? We'll update the balance, which should be relatively straightforward. But there is a bit of a problem with functions and how you can actually update the values. If you retrieve, you can play around with all kinds of things. It's all great and good. But if you want to actually update things, it won't work exactly like that, because the transaction will come from the caller, right? So you'll need to commit the transaction from the caller. You can't just do it directly as such. You have the caller's transaction where you have your select, whatever, and that's where you can actually commit. You cannot commit inside a function, and we'll prove that with this little example now. So let's call it balance transfer, very simple. Let's do the language. In this case, we'll do a little different sort of language arrangement. We'll do PLP, see, PLP, GSQL, like that. So it's a different language. And I'll explain why once we get to a start procedure, it will be sort of a bit more clear. Let's do it like this. Okay. A little trick to get it to work, and like that and like that. Well, we can actually, it makes it a bit easier if you do it both at once, and that should have worked. Let's see if we can actually make it work. How we can. So the editor isn't perhaps the best, but realistically other options are even worse. And the DBeaver arrangement is actually quite good if you're migrating from SQL Server. Something not too complex, of course. For that you need all kinds of additional arrangements. We could certainly migrate some simple projects from SQL Server to PostgreSQL with their native tools. It works quite well. It's been tried, and it's not too bad. And you can actually use this visual interface, not some console arrangement or something sort of in that sort of a way. So let's move on. Let's see what we can do here, and let's do a little update. We'll do the same in the next thing in start procedure. Let's do accounts. Let's do set balance equals balance. So we are updating balance, and that is minus the amount. Do we do minus the amount, or we can do plus the amount actually? Well, if it's a transfer from the account, let's do minus. It doesn't really matter if you do plus or minus. Just a little sample here. Let's do properly where ID equals account ID, like this. It's giving us suggestions, but not the correct ones. Okay, so that's good enough. We have a balance, we have a calculation here. Perfect. So now, of course, we would want to commit. Let's also add a little begin and end for the transaction, right? And then we can add a little closure here, and then we can commit. So normally you would expect the commit to work, and that's our function, and that's great and good. So let's try and execute. Okay, so we have our function here loaded and ready. It's been added, it's all great. Now let's get rid of it, and let's do a little select. Let's see, what do we call it? Balance transfer. Balance transfer, and account one, let's say 100. So it adds 100. Perfect. Now if we execute, we get this nasty error, right? As you can see right here, we have PL function balance line for at commit. At commit is where the problem is. So now let's try to alter the function and see how that works. Now to alter the function, I brought back this wrong one, but the interesting thing about altering a function, you don't have to remove it. You can alter it, sort of. But if you use alter function, it's only for something like this, the return type or one of the parameters. You do not alter the body. What you do is you do create or replace. So that way, if it is there, whatever changes you make, it's replaced fully, and that's it. There's no sort of direct alteration, which doesn't matter too much. It won't hurt us at all. We can remove the commit, right? This will fix the underlying problem, and then the function should work at least to some extent. So now we have this, it's running, it's all good. The function should be updated, it's all great. In fact, to make this a bit quicker, I will copy this, the name of function, so we can then, what we can do is we can select like this, and let's see, balance transfer, all right? And before we do that, we'll do a little check, because we don't actually know if it will change or not, because we want the value to be updated. We want it to change. So select from, let's see, account stable like this. Let's execute this. We have 500. So if we provide ID 1 and 500, and this amount will be, let's say, 100, right? So let's do it like this, 101. It should become 600. Now, if I just run it, of course, no real result. And here we have a result, right? So you don't need commit. There's no reason for it here. It will commit on this, on the caller essentially. That's how it will be. So you can't use the inside the function. Now, if you do have to use it, say you're looping through several iterations and doing these begin commits, and you want to perhaps roll back the transaction inside your definition of something, then you have to go to stored procedures. So now let's look at how you can use a stored procedure. So for the stored procedure, we have something relatively straightforward, but a bit more complex than the function. So let's create it by writing create. And in this case, instead of function, it will be procedure. Almost exactly the same still, right? And let's say, let's apply monthly interest to all these balances. Monthly interest, that's how you type it in. And we have rate. Let's do numeric for the rate. Very simple, very straightforward. Again, almost exactly the same as the function. And if you're coming from the SQL Server world, you'll notice the way we place those parameters for the procedure as well as the function, it is a bit different, because in SQL Server you would have as, and then you have your declaration somewhere here. So there is a bit of a syntax difference. In general, the syntaxes aren't that different, but there are a few differences to be aware of, but you can certainly switch from one to the other quite easily. So then we also need to declare a language. And the language, in this case, will be pgSQL, the fancier one. Basically, what this allows us to have, not just your general select, update arrangements, but it will also have things like if statements and for loops. So if you need that, use this language. If you don't, just use SQL. It doesn't matter at all. And then as, let's see if we can actually do this without interference this time. Probably not, but oh, it works actually. That's fun. And now we can actually start typing a few things. We will do a little for loop, so we will need to declare a few things. First of all, let's declare row type accounts, we'll call it. See, as, yes, that's how it should be. Let's call it accounts, and that's gonna be separated as row type. Let's see, like that. Perfect. I believe that's how it should be. We'll see if we get an error. It can get a bit complex here. The syntax checker here, it kind of works, but kind of doesn't. So it's always a mystery in the end to see if it worked or not. But we have declared account types, and you'll see soon why we need that. Essentially, we'll try to loop from the accounts, and if it matches a certain description, if it's, well, we don't really have any sort of filtering here in this case, but we'll basically apply, and on each iteration, the idea is that we commit a database. So we don't just sort of run through everything and update, and then at the end we commit it. We commit at each iteration. Now you could commit at the end, and then if something fails, you do a rollback. So that's what the rollback would be for. But let's just do a simple commit so we can show that commits actually work here, and that's why essentially stored procedures were introduced in PostgreSQL. Back in 2019, I believe. So let's do a little for ACT, our accounts, and select, and then let's do from accounts, right? So we're just essentially finding account in accounts, nothing too fancy. Again, you could add more sort of arrangements, but of course, something to note is the order by, so we don't get lost, and that's gonna be a loop. So the syntax doesn't know by itself that for is a loop. You need to actually declare that it is a loop, which is quite interesting as far as syntaxes go. But we have for, we have loop, and that's a for loop. That's perfect. And then we can do something with that account in that loop. The main thing, again, this language allows for and for ifs and for all these things. SQL, that's a different story. So let's just do a simple update. Let's not extend this too much. I believe it's accounts. And let's do set. Let's do properly. Set balance like this, just like we did here, but in this case we are applying interest for the balance, not for deductions. So we have balance rate, and then let's do where, let's see, ID is account ID. So essentially we're looping for really not much of a reason here. ACCT should be fine here. Yes, ID should be fine as well. And now we have this update, and on each iteration we can commit like that. So we commit, and that should be saved right away, not waiting for the next iteration. And you also might be calling functions from here or doing something of that nature as well. Maybe on the rate to select the other function, all kinds of things you can do, and sort of mix and match them. So again, when you have a function, it really should be reserved for maybe a little calculation, maybe adjusting numbers so you can compare with if statements on the actual store procedure. Or maybe you just have if statements inside the functions, certain functions in certain fields for filtering and things of that nature, and then just return simple things from store procedure. One thing to mention, speaking of returns, there is no return type as such for stored procedure. So you just return whatever it is, and then you figure out what you actually returned. That's quite interesting because you don't have to declare it. The only thing we have to declare is a sort of variable for the for loop. That's why we're using that. So declare is not a mandatory thing here. It's just an addition that you can use. Before we forget, let's do and loop. So you need to start the loop like this. For the type of a loop, essentially how it works, and then loop starts and loop ends. No start loop, just loop, and end loop to end it. And let's add a little fun thing here. This is how you can create a sort of a comment or an error as well, if needed, essentially on what action was taken in the database. Quite useful if someone else needs to take over from you and they are only running perhaps these functions, they aren't really working on them. So if you add these notices, it can make someone's life a lot easier to maintain these things. So let's do raise notice. And let's do committed interest, let's say. Let's not be too uh, fancy with this stuff. Actually, we can do committed interest for, I believe, like this, and then we can do, let's see, ACCT, and then owner. Let's see, owner, of course, there's no suggestion for the owner, but that's not how it's spelled. Okay, perfect. That's how it is. So this will raise notice. Essentially, every time something gets saved, it will print to the console, and whoever's using your fancy arrangement here will be able to do it. Now, all we have to do is run it. And let's see, we have a bit of an error here, so let's investigate. So as far as the error goes, it's a bit of a weird one. The syntax is kind of troublesome sometimes here, but basically we can close it and sort of get rid of some of this stuff. But as you can see, I went a bit further and actually found the bigger problem, which is sort of easy to miss, sort of not. This will still actually fail when you save. It doesn't show any errors, but it will still fail because we provide a parameter here for this notice, but we don't say where it should go. So we need a little percentage sign here. Now, if we add that, it should work perfectly fine. And now, as you can see, it is created. So again, the errors, they are what they are. You want to close it because it will throw random stuff. But again, raised notice does require, if you add a little parameter to display from what you have there, you need to put percentage sign so it knows where to use. And this is similar if you use C#, you have the same sort of arrangement in the rights. So that's the next one, that's the next one, however many essentially parameters you would have here. So alteration, create, or replace, that's how you do it. And the rest of it is about the same. As for functions, of course, procedure can do commit. Procedure, both function and procedure really can have this pgSQL, remember this, to have ifs and all these other things. And then declare is not mandatory, but whatever we provide as parameters here for sort procedure, it's the same way as function. Now, let's get rid of it and actually try to call the function here. Very simple arrangement. In fact, I will copy just so it's a bit quicker. Let's get rid of all of it. Let's do select. Well, actually not select in this case. We're calling a procedure. We will do select. We need to call. You call the procedure, you don't do select, and you can't really select it as such. So you have to call it, and that's going to be a final result. And procedure should really be used when you're calling it from some perhaps language, or your final result that wraps essentially all the functions that you might have in there, or when you need the commits, of course. So perhaps input only, perhaps output as well. Depends on your arrangement. We have this copied. Let's say do 5 interest. That's, I think, kind of believable. And let's execute that. And we have a little error. So this error is actually coming from the sort procedure itself. We have accounts instead of account. That's a little problem. Let's replace it. Create or replace. As mentioned previously, it will work perfectly. Let's do create or replace like that. And it's now replaced. And now let's just call it quickly, because we're taking too long with those errors, but that's what happens. That's real world sort of arrangement. It's very easy to make those tiny mistakes, and they are tiny mistakes, but they ruin the whole operation as such. And again, something important to kind of point out here, we got that problem only after calling the sort procedure, not when it was being created. So it's something also to remember. Not everything will actually work when you create it, so it's always good to test it. And now we have committed interest. Right here we have committed, committed. This is our little race thing. Now, in one of the next videos relating to PostgreSQL, we'll take a look at how .NET can work with stored procedures, how you can call it from .NET. If you're interested more in entity framework, we have a whole series of videos on this channel. There's anything from getting started, migrations towards full text search, and we will soon have a video on RAG arrangements and embeddings and all those things. So quite an interesting topic here. And with that said, we will conclude this video.